Alright, let's take a look at worksheet number 2 here of G-GMD.A.3. This is about calculating prisms still, but in this case we're going to look at composite ones. In other words, prisms that are made up of a bunch of little pieces to make the big one. Now sometimes there's kind of two approaches to this. Sometimes people think about like something like this, and they want to think about the volume of like this piece, say, calculate that, which is fine, and then calculate, this additional piece and basically add its volume on. So kind of do it like two chunks, one volume chunk added to another volume chunk. That's perfectly fine. I tend to teach it using the same principle, that stacking principle. So in other words, I'm going to find one area and multiply it by the height to get volume. So I do it all as one question, and that's just a preference thing. But you can do this as like two chunks or three chunks or whatever. So what I'm going to do is I'm going to do volume is area of the base times the height of the prism. And again, that big B represents the area. So what I'm going to do is I'm going to kind of cut it into two pieces and find it. So the double dash and double dash are the same, so that's 10 divided by 2. So this is a 5, this is a 5. 8 times 5 is 40 here. 5 times 5 is 25 here. So actually all I do is put 65 in there and multiply it by 6. Do you understand what I did is I found one region, one common base. This base is the same in the front as it is in the back, and so I'm able to just do that. And 40 and 25 comes out to be 65, and then I multiply that by the 6, and I get 390 centimeters cubed. I like that way. I don't know. Instead of doing a bunch of little ones, I like to find the full region and then just multiply it by the height. Let's do that here as well. We're going to find the area of that base. Now, there are actually two ways, well, there's more than two ways, but two general ways to think about this. Again, you could cut it up into a bunch of little pieces and figure things out. For instance, so this is 7 times 2 is 14. This is 8, 2, and 6 for 16, so that's 16 times, now that's 7, that leaves 9 here. So that would be 16 times 9, which is 144. And then here we have 7 times 6 for 42. So one way to handle this is to add those together. 14, 144, and 42. We get 200 there, and then the height is right here at 5. So we get 1,000 centimeters cubed. Let me give you just a different approach to finding this number right here. Let's see if you like this better. I see some students, instead of adding all the little pieces up like I did, they see this as one big rectangle. And in this case, and it's dimensionally kind of messed up, but 16 times 16, so 256. And then they say, how big is the whole? So they know the whole region in the front face is 256. And then this is 8 times 7. So you subtract 56, and guess what? You obtain the 200 that way. Whatever you like. Here, there's a nice little 60 degrees here. Actually, you know what? Maybe I've given too much information. Let's do it this way. A little 60 degrees here. I drop this down and I get a 30, 60, 90 triangle. Now, if this whole thing is 12 and this is 8, that leaves me a 4 here. And 4, and then the long side is 4 root 3 in that case. Now, I could do this as two composites, like a triangle and a rectangle. I could just do those, add those together. I actually now recognize that this is just simply a trapezoid, and so why bother doing that? I'm just going to do the area of one base times the height, which is 1/2, and I'm going to do 12 and 8 and a height of 4 root 3. That would be the area of one base, and then multiply that by 11. So this is 20 divided by 2 is 10. This is 40 root 3 times 11. And then 40 times 11 root 3 is 440 root 3 centimeters cubed. So I was going to do that as like a triangle and a rectangle, add them together, but that's what the trapezoid formula does anyways. So here's a couple examples on what you're up to. I like to think of it as one solid face times the height, and then that way you get that whole principle of stacking area to get volume.